Okay, our next keynote speaker is going to talk to us about systems innovation in the cognitive era. So please give a warm round of applause to the General Manager at IBM Systems Client Success, Mr. Paulo Carvao. It's good to see you. Welcome.
Hi, good afternoon, and thank you for joining us this afternoon, in which we'll continue a conversation about artificial intelligence, or sometimes how I would like to call it augmented intelligence. So I think it's a good continuation of the previous talk. We'll talk about some of the practical applications of what we have just discussed and what is happening today. The reality is that the world is changing, or the world has changed. Everything has changed. The way we live, the way we interact with each other, the way we communicate and consume goods, the way we work, and the way we do business. Sometimes we used to call this the cognitive era, which is an era fueled by some of the techniques that we have just discussed in terms of machine learning, deep learning, artificial intelligence, and fueled by an inordinate amount of data. As we look forward into the future, competitive differentiation will now be dictated by the ability that companies or individuals will have to derive insight from the data. Looking back over the last probably 4 decades or so, we have automated business processes. And by now, most of the business processes are already automated. The next stage now is around cognition and deriving real-time business insight from data. Now, in order to do that, we require a lot of innovation. And we see this innovation coming in 3 different flavors. Technology innovation by itself, innovation through collaboration and through open ecosystems, and finally, innovation of business models. The transformative power of technology that will fundamentally alter the way business is done today. So let's talk a little bit about each one of those. So the first one is technology innovation. So we at IBM, we constantly do market surveys and go to business leaders and have discussions about what type of phenomena would have the highest likelihood of disrupting or empowering their businesses. And during our last survey, technology has gone to #1. So in the view of chief executive officers, today technology is seen as the #1 factor to change the game from a business perspective. So what kind of technologies are we talking about when we are discussing the cognitive era, when we're discussing a world fueled by artificial or augmented intelligence? So here are 3 examples of these technologies. One is around acceleration or accelerated computing. The other one is leveraging cloud technologies. And finally, blockchain for transforming business processes. So first, talking about acceleration. If we look about, or if we think about where we have come from in terms of generating incremental compute power over the last 3-4 decades, the whole industry has been riding Moore's Law. Moore's Law basically was the power of miniaturizing microprocessors or transistors into a silicon die, and by compressing more and more of these transistors into a silicon wafer, you would create more and more sophisticated microprocessors. Now, as you do this, you will eventually hit a physical limit. Today, we're operating with technologies around 22, 14, going to 10 nanometers. After that, 7, maybe 4 nanometers, and you're getting to a point in which the size of these transistors is such that you can no longer hold any electrical power into them, and you're just holding a handful of atoms. So you are at the limit, at the physical limit of that technology. And therefore, for you to continue to drive innovation and to continue to drive capacity, you need to now no longer innovate by miniaturization, but innovate at the system level. Hence, now, accelerated computing, in which, in addition to the traditional CPUs or central processing units, you will start to offload part of your work to accelerators so that you can execute complex, deep neural networks like we discussed in the previous talk. And in order to do that, you have to have techniques to have coherent acceleration and coordination between the central processor and this potential array of different accelerators, be it a GPU, an example that is commonly used today for executing machine learning, neural networks, deep learning, or FPGAs, or field programmable gate arrays, or even, as just discussed, a quantum computer as another one of these examples of an acceleration unit. So this is, concept number one, is we're getting Moore's law to a point in which it will saturate, will no longer be able to deliver incremental capacity and capability only via miniaturization, and you need to start to differentiate at the system level, and with that, leverage more accelerated computing. Now, in addition to that, if you're dealing with insight, an insight derived from data, you're dealing also at the same time with an explosion of data. Explosion of data, be it on a structured data or unstructured data. And the ability of deal with massive amounts of compute or massive amounts of data, leveraging the cloud together with your existing infrastructure. That's what we call a hybrid cloud, is the ability to leverage at the same time public or private clouds, workloads that are in your business or outside of our business, and how we are developing systems that can handle those capabilities. And then finally, more innovative technologies like blockchain that create encrypted, secure networks that can revolutionize the way transactions are executed today. So a very common example of blockchains are cryptocurrencies. But in addition to that, and we'll talk more about this later, we have the application of blockchain techniques for optimizing or even disrupting supply chain. So this is, the first of the topics, how technology and technology innovation is starting to affect and change the game. So let's talk about an example of where this is being put to practice. So this is the Korean electrical power company, and they manage the network of electrical distribution systems in Korea. And as in any of these networks, you have a very large array of transmission towers. Taking care of those transmission towers and making sure that they're constantly available, that you don't have any issues, that you need to maintain them in time, is not only a very important task, but also a very expensive task. So how is KEPCO doing this today? So they're deploying drones that go out in the field and take pictures of these electrical towers. And then these pictures are sent back to a central processing location in which, using techniques of machine learning and artificial intelligence, the computer will take a look at these pictures and will differentiate, for example, if you have one distribution tower that is starting to show signs of rust, and it will say, okay, so this is normal wear and tear. On the other hand, this other tower here are getting rust to a point in which it is about to collapse. And I need to immediately dispatch a maintenance crew to intervene and and take some action. So if you think about this, and compare to the way this used to be done, you would have to have surveillance crews and maintenance crews going around the country, inspecting all the towers, experts that would be taking a look at each one of those towers, and then making a determination as to whether maintenance was required or not. Now, all of this process has been transformed and automated using all of the techniques that we've been talking about. So the ability of, number one, collecting all of that data, then transmitting it to a central location, then still without human intervention, having a diagnostic being issued, and then at that time, dispatching a crew for maintenance. So it's an example of using accelerated computing, machine learning, Internet of Things to capture data, take action, and change and transform a business process. So the second one of these elements of innovation is innovating through open ecosystems. So how we, through industry collaboration, can look at areas of adjacency to what we do today, and with that drive innovation at a faster pace. So once again, 70% of the clients that we have surveyed indicate that they plan to drive their own research and development activities and innovation through leveraging their network of partnerships. So this is one example that we are doing, and how through open collaboration and the creation of open ecosystems, we're also accelerating development of our own hardware technologies at IBM. So these are two initiatives that we have, one called Open Power and Open CAPI. This is, we have started Open Power about 3 years ago by open sourcing a lot of our technology for the power microprocessor. We started the foundation with 5 initial members, were IBM, Google, Mellanox, NVIDIA, and Tyan. And 3 years after, we have more than 300 members in the foundation driving innovation through open collaboration, through open standards, and bringing to market new hardware offerings faster than what any of us could have done by ourselves. Then, in addition to that, if we go back to the dialogue that we had a few minutes ago in terms of accelerated computing and the need to flow data in a coherent way between the CPU and accelerators, we also wanted to have an open standard that would enable you to do that transmission of data or implement that protocol. That's what we call Open CAPI. That stands for Coherent Application Processor Interface. So we published this standard in was third quarter of last year. Today, most of the industry has adhered and share on our vision of a future with heterogeneous computing and the need of fast transmission of coherent data and processes between CPUs and acceleration. So one example of what we're doing to drive new systems design, do this in an open way, and so now, for example, for our next generation of power-based systems, we're going to be launching our own systems together with Google that will be launching their own power-based systems and deploying them in their own data centers, and bringing to all of the market technology, again, faster than we would have done if we were doing this individually by each one of us. And finally, the third of these areas of innovation is if you innovate the technology itself, if you do this in an open and collaborative way by leveraging open ecosystems. The third one is how you can innovate even at the business model and the business design level. So the next element of our survey is now 80% of our chief executives are experimenting with different business models that can fundamentally disrupt or fundamentally alter the way they do business today. And behind this, another fundamental and foundational set of technologies is through blockchain. So I would say it's almost like a companion thought to everything that we have discussed in terms of artificial intelligence, machine learning, deep learning. Then it's how can we reimagine how we do business transactions today by implementing blockchain technology. Without getting into deeper concepts about what blockchains are, but think about it as a mechanism for you to automate transactions across a network of participants in which you maintain the privacy of each one of the members and their associated data sets or transaction sets. You implement this through a shared ledger in which each one of the participants share that ledger, and alterations to that ledger can only be made on a consensus basis, meaning that a majority or all of the members of the network need to agree that that alteration is a valid alteration, and with that, you create this concept of a smart contract, which is a self-governing contract that can be encrypted and therefore tamper-proof. So this has fundamental implications in terms of what you can do and the impact that you can have across multiple industries, be it securities, right? Be it trade finance, loan originations, supply chain, and etc. So many real examples being already used today. We have, for example, companies like Walmart doing tracking of food traceability and food provenance. We have companies like ourselves, IBM, in which we do financing of technology for our clients, and we have automated the process of invoice dispute with clients by using blockchain, again, bringing the participants of a network together around one ledger, and with that, avoiding all of the debates that could be happening in a case like that. So this is one of the recent examples of what we have done with a company called Northern Trust, which is using blockchain to help transform their private equity administration. So real examples of implementation today already in production live around the world of these technologies, right? And so what we're doing then from a systems perspective is you need to have the infrastructure in place to be able to deal with all of this innovation. You need systems that have to be able to deal with the massive amounts of data from which we're going to derive business insight and cognition. You need to have the capability to process this information in limited amounts of time, hence accelerated computing. You need and have at your disposal cloud capabilities so that you can combine this with your existing application assets or what you have available on the cloud. And finally, you have technologies like blockchain that can fundamentally transform and alter the way you transact today. Now, this is the beginning, right? So we are at the beginning of this cognitive era, going back to the discussions with the professor in terms of exponential acceleration. This is just the beginning, right? And if we think ahead, and all of the things that we're doing in terms of driving innovation beyond the silicon as Moore's law starts to saturate, all the advancements in cognitive computing, the creation of next generation cloud architectures, and our first forays into quantum computing, including what we have made available last year through the quantum experience. And earlier this year, we formally announced IBM Q, which is quantum computing capabilities available via the cloud for the world to experiment and generate the next generation applications that would be taking advantage of that technology. And back to this thought of the exponential growth, our view today is that the stage that we are with quantum computing is equivalent to where we were in the 1940s for traditional computing. And if you think about where we were in the 1940s for traditional computing, this is the days of Turing, the days of von Neumann, in which they were starting to define the very, very basic fundamental abstractions that eventually created the digital era and the computers as we know them today. This is what's happening with quantum computing today, is us trying to define the initial set of applications and use cases that would be taking advantage of this technology. So welcome to the beginning of the cognitive era. We have a fascinating journey ahead of us, but a lot of this is a reality that is in place already today. So thank you very much. I appreciate your time.
Got time for one question. I wanted to ask you about blockchain technology. Yesterday, one of our favorite speakers here, Mika was here from Finland, and he was all excited about blockchain technology being used in rental car business. What do you have to say about that? Because he said it was going to prevent thieves from changing the tactometers to actually, if they want to make you think that the car has only been driven for 5,000 kilometers instead of 50,000 kilometers.
Well, if you think about, consensus-based algorithm, and if you have an entity that would have to certify the mileage, right?
Yeah.
The thief wouldn't be able to make the change by him or herself, right? So that's kind of the essence of one of the potential applications of a shared ledger.
But you think it's a good idea?
Consensus-based. Well, I think it's anything that would drive certainty into business transactions. It's a better idea.
Good.
Okay.
All right. Thank you very much.
Thank you very much.
Presentation. Thank you.
Thank you.